Thank you so much. Hi, everyone. So, good morning, good evening from wherever you're joining from, and thank you so much for joining. Uh, Let me just go ahead and share my screen real quick. Um, just let me know, Shari. Sorry if I mispronounced your name. Let me just know if you can see my screen now. I think you can. Okay, let's good. Let's get started with. So let me briefly introduce myself again. My name is Aashi, and I am a Google developer expert in machine learning, subcategory of generative AI. And I am currently pursuing masters in Georgia Institute of Technology, Atlanta. And today we'll be learning about Gemma models. So I hope all of you are well aware of Gemini, or previously known as Bard, and have used it in one way or the another. Maybe, throw some text into it and ask some questions, maybe give it some images, some videos, and ask about the video or what kind of thing is sitting in the image or something like that. But Gemma models are kind of same, but different in their own way. So Gemma open models are a family of lightweight, state-of-the-art open models that are built with the same research and technologies that was used to, create Gemini models. But Gemini models were multimodals. They were, kind of models that you throw any kind of data at and would give you good results. But at the same time, we wanted some special models that would handle just our language approaches. So here comes Gemma. Originally, Gemma models were language models. So we wanted Gemma models to take in text and return back text, maybe summarizing, maybe question answering, maybe write an email for me, something of that sort. So, but if you see my previous slide, I say Gemma open models. But why open models? Simply because open models are the models that are free access to model weights. Sometimes, if you are really active on Twitter, you'll see now they call them open weights models because their weights are open and you can fine tune them, these kinds of models, on your you know given data set, any kind of data set, maybe your personal data set, right? So you can fine tune them according to your needs or according to your use cases. But of course, you have to follow some kinds of use terminologies, redistribution, some warrant ownerships, and all that are specified by the company to which these originally belonged. So these models are open to use by individuals, researchers, students, and commercial users. I have myself experienced that these models are at par with all other existing models in the same space. However, developers need to agree to commit to developing some uh, the use cases from these models quite responsibly. It comes under a part of responsible AI. We talk a lot about responsible AI, and open models takes the next step into these models. Because these models are open, they are open to a lot more noise than just good work. These models are open to anything wrongful or anything rightful at the same time. So it's our as developers responsibility that we commit to developing or developing use cases that are responsibly active in the field as well as very responsible towards the people who are going to use your product or applications. Next, how are these models trained? Just I told you that these models are open models. So where do we get all the data set for these models? Of course, the companies are not going to tell you where these model data set came from, but yes, there are few sources, a wide variety of them. So totaling around 6 trillion tokens, including data from web documents. So when we talk about web documents, it can be anything, say your, some text, some emails, junk emails, some kinds of summaries that people wrote, some essays that people wrote, all those things that are freely available, royalty free on the web. That ensures that model is exposed to a range of linguistics, topics, styles, and vocabulary. So primarily, these Gemma models were tuned on English language content. So they are pretty good with English languages, but the base Gemma model does not perform that well on any other kind of language. I tried it myself to ask it some mathematics questions, but yeah, it did not do that well what it did with English languages. But at the same time, it was also trained on data set that was mathematical. So mathematical text like reasoning, logical reasoning, symbolic, some mathematical queries, some equations, all those kinds of data it was also trained on. Then coding. It was exposed to coding languages, syntax, programs, programming languages, and to generate different types of codes, code snippets, and even understand the code related questions. Next come the applications. I don't think so that I really have to share the kind of applications these models are capable of, because of course we all use LLMs these days and we know the wide variety of applications they have in industries and other domains. So let me just take you quickly through this. First is text generation. Of course, we use Bard, ChatGPT for different kinds of creative text. If we want to send a cold email to someone, we'll just ask, Bart or Gemini to do that. We have chatbots and conversational AI. We have text summarization. I like to do it personally, even given any research paper that I want to read, but I want a summary of that before reading. I just throw it into Gemini and ask it to give me a summarization. Then NLP research. Most of the researchers nowadays are doing the same kind of thing. They are applying these kinds of models to understand how they can do better with the kind of thinking, the kind of cognitive research that a human mind does, and match the level of humans at the same time. Then language learning tools. You can use these tools to, aid your grammar correction, learn new punctuations, practice writings, etc., etc. And finally, knowledge exploration. You might come across different kinds of words, different kinds of problems, questions that you want to ask, but rather than going just for a Google search, you might ask just these models. Well, that was kind of a boring part, a lot of theory. But what are Gemma models and the variants as well? So, Gemma models, the originally was the Gemma 2 billion model or the Gemma 7 billion model. But we do have a wide variety of Gemma models that are tuned, pre-trained, and can be fine-tuned for different kinds of use cases. So here it is. Gemma model, the Gemma base model, or I should say that Gemma base model is a lightweight text to text decoder only language model. When I say decoder only, think about the transformer decoder part only. The transformer original paper, think of the decoder part only, right? Trained on a massive data set of text, code, mathematical content for NLP related tasks. So Gemma was the base model. But then came these three varieties: Code Gemma, Recurrent Gemma, and Pali Gemma. So Code Gemma is actually that helps you. Uh, its foundations remain the same. That is the Gemma model, but it is a more powerful model that helps you with code compilation, writing code, generating code that fits into your local computer. Then comes the Recurrent Gemma. Recurrent Gemma is bit different from original Gemma, the kind of Gemma model that you think of. It uses recurrent neural networks, or what we call RNNs, and local attention to improve memory efficiency as well as reduces your computation. So if you want fast inferences, you may look into recurrent Gemma. Then comes Pali Gemma. If you are very, very active nowadays on social media, maybe Twitter, LinkedIn spaces, you'll find a lot many examples of Pali Gemma. People are using them a lot and giving out different kinds of experiments, examples that you can try with it. And we're gonna do the same this time. So Pali Gemma is an open vision language model. It's a VLM, what we call. So if I refer to VLM, just think about Pali Gemma, that is vision language model. So it is actually a class-leading fine-tune. It has class-leading fine-tune performance on wide variety of vision language tasks. So basically, I give you a hint. Think of, say you have a picture of a cat, right? So the picture or the image is the vision part. Then I ask a question, what is the breed of the cat? That is the language part. And put those two things together, that give it to a Gemma model, that is Pali Gemma model, right? And it will tell you which is the breed of that specific cat in the image. That is what Pali Gemma does. We'll discuss it in more depth as we go forward. So first we just discuss about base Gemma base model and what are its capabilities. So personally, when I worked on Gemma model, I'll show you a project showcase as well. Gemma model is kind of a powerful model when it comes to deploying it on your mobile devices or on your desktops. If you want to use Gemma models locally, they're also available through Olama. So you don't really need internet as well. You can just download Olama and it gives you access to local models such as Gemma as well. So you can use it on offline as well, right? So Gemma based model has two parameter size. That is the 2 billion and the 7 billion. Input, both takes text as input and gives text as output. Both have a pre-trained model and an instruction tune. Now understand the difference between pre-trained and instruction tuned. Pre-trained models are trained on a data set that is open, that is kind of a free form. So it has knowledge of everything. While instruction tuned is a model that you can fine tune on your own data set. So instruction tuned, that is usually referred as IT, and pre-trained model is usually referred as PT. So if you see anywhere PT written, that is for pre-trained. And if you see anywhere IT written, that is for instruction tune. That means we are fine tuning that model, or it's a fine tuned model, right? So 2 billion, it's 2 billion parameter size is quite small and can fit into intended platforms like your mobile phones and laptops, while 7 billion is good enough to work on your desktop computers or small servers. Also, if you're well aware of Keras 3, backend feature, it allows you to work with these models using TensorFlow, JAX, and PyTorch. And of course, if you're a cloud person, Vertex AI has all these models available for you in the Vertex AI garden, model garden, and you can just give them a try there as well. So tuning Gemma models. As I already told you that Gemma models come in two different versions. One is the pre-trained version. So pre-trained version, these are the models that are not trained on a specific task or instructions, and they are not deploy. You don't deploy these models without performing some tuning. Then is the instruction tuned model. These models are trained with human language interactions and can respond to conversational input like a chatbot, right? So the model knows what it does and how it does. This is an example of deploying Gemma 2 billion model on your mobile, on an Android device. So understand this path by path. Say, for example, you are a student. So recently, class 10th and 12th people had their exams, or maybe any student who has their exam. Say, for example, you have a book, see a science class ninth textbook here, right? So you have your science textbook. So what we did was we took the contents of this book, converted them into a CSV file, not any CSV file. There is a particular technique for data preparation. So what the CSV file would look like was three columns. One had questions, one had answers, and one had context. And combining these all three columns, we had our data set ready. Then we fine-tuned our Gemma 2 billion. See, IT is for instruction tune. You can fine-tune it. IT based model, we fine-tuned it on our data that we prepared using LoRa weights. And then we did our inference. Of course, if we wanted to, deploy it somewhere else, like we deployed it on Android, we use MediaPipe, GenA Converter. So we got a model that was the size that would fit our Android application, Android phone. So the Android application was around 2 GB. That is much smaller than any, game that you download these days, right? So you can just get inference that is even without your internet. So think about that. You have a child whose exams are approaching, but they want to practice their question, their skills, but they have some questions and queries. You don't want them to go to internet, because once they go to internet, they'll search something, they'll move to something and then something, and eventually end up playing games. But what you can do is you can take the whole textbook, convert them into a data set, fine tune the model, and just deploy it on the phone using MediaPipe. Now they can just ask the question. Say, for example, we ask the question saying, "What is the momentum of object of mass 5 kilograms moving a velocity of 2 meters per second?" And we got the answer that momentum is mass into velocity. Therefore, momentum of object is 5 kgs into 2 meters per second equals to 10 kgs meter per second. I don't know if that's correct or not, because it's been a long time that I did my science. But yes, it got you some answers. Yes, of course, there are hallucinations. And I agree if you say to me that yes, LLMs hallucinate. But LLMs hallucinate, and there are multifarious ways you can work around them. Maybe do better prompt engineering, maybe add some gates or something else, some bars to fixate that it does not hallucinate beyond a bar. But these are kind of examples and projects that, as a college student or as a student or someone who wants to practice their skills and make some projects, these are some of the projects that will help you to move out of your comfort zone and try these things on your hands, right? So that it will make a good hands-on project for you. Next, we'll turn to Code Gemma. So Code Gemma is a collection of powerful lightweight models that can perform a variety of coding tasks, like fill in the middle code compilation, code generation, natural language understanding, mathematical reasoning, and much more. So I found it very fascinating. For Code Gemma, it does two good things, and these examples are available freely. You can try them yourself. And what it does fill in the middle code compilation. So what it does, you give it the starting of a function. Say you have the name, say sum of two numbers, and you pass it whatever, say a and b, and in the end you write return sum. It will fill in the middle logic by itself and give you the whole code. That is the best part about Code Gemma. Also, it does another same thing, that you just give it a prompt that you want such code, and you give it some examples, and it will generate the code accordingly. I will show you some examples in some time. But the variants, let's talk about them. Code Gemma models are text to text or text to code decoder only models. But these have three variants. First variant is 7 billion pre-trained variant that specializes in code completion, generation from code prefixes or suffixes. That is 7 billion pre-trained model. That means it is a generalized model. It specializes in code compilation. It is trained on codes and codes only. It can generate codes for you. It can complete code for you from prefixes and suffixes. But at the same time, 7 billion instruction tune variant is for natural language to code, like a chatbot, where you just tell it, like you do with Gemini. Just you tell it that, okay, I want this kind of code, and it generates that for you. It follows your instruction like a chatbot, right? So that's why we call it instruction tuned as well. Then is the state of the art 2 billion pre variant that provides you 2x faster code completion. But the thing with these models is, especially Code Gemma and Recurring Gemma, is they are something that is already under process. So if you try it and you say, oh, I didn't get a good result, that's simply because they're under process and they are getting better over time, right? These are pretty new models in the market, so give them some time to develop. So here is an example for Code Gemma, how you can create an AI assisted, you can generate AI assisted code with Code Gemma. So first, you have to select the kind of model that you want. Here, it's Keras NLP. From Keras NLP, you get the model that is Gemma causal LM model, and you pass in what kind of Gemma model you want. So I said Code Gemma, 7 billion model, EN is for English. You load that model and you get the model summary first. So this model uses Gemma as a backbone. See, we already said that these models are built on the Gemma base model. So of course they use Gemma backbone and then they are built according on it. Then you can do a pretty simple task like generating code using like few codes of line, right? Code Gemma 7 billion pre-trained model is trained on natural language corpuses, so you can just use your natural language, human language, and write a prompt. So my prompt was write a Rust function to identify non-prime numbers. And I gave some examples as well. So for example, you're telling it, uh, okay, write the function to sum two numbers. And then you give some examples as well. Say this plus this is this, 10 plus 2 is 12, something of those sort, right? So here I told it explicitly that write a Rust function to identify non-prime numbers. And the examples that I gave was is not prime. That is, I passed it that what kind of function name I want and what kind of parameter I would be passing. So it identified that, okay, the function name should be is not prime and I'll be passing it an integer that is 2 or something else. Then I also passed it that, okay, the answer would be false for 2 and for 10 it would be true. Then I told it the starting line of my code as well. That is a pub function, the function name that I want, the kind of input I'll be giving, and of course the boolean, the return function, what I want in return. The return variable should be a boolean, right? Then a single line of code. That is the model that I'm using dot generate. That this is very generic in all kind of models that you use nowadays. So any model that you usually take from say Hugging Face as well, you can just use dot generate or dot generate content and you pass in the prompt, the model or some token size and it gives you the result. So it's very generic to use. So dot generate, pass in the prompt, the maximum length of the code that you want to generate, and it will generate you some code. Next is recurrent Gemma. Recurrent Gemma is a family of open language models. It's again from open language models family, but as I told you earlier, that it is built on novel recurrent architecture that is developed at Google. So recurrent architecture is that recurrent neural networks or RNNs. These are well suited for, of course, text generation tasks like question answering, summarization, or reasoning. But why it's novel is because it requires less memory like than Gemma and achieves faster inferences than generating longer sequences. So recurrent Gemma is something that is still in process and in progress. And I have not tested it myself, but I have some examples for you in this as well. So it takes in a string of a text string, like say a question, a prompt, or a document, and it returns back in English a text response, an answer to a question, a summary of a document, something like that. Note that all these models are tuned are available in English language. That is something to think about because the most of the data is available in English. A large amount of data is available in English, so most of them are tuned in and available in English. But there are models that are multilingual as well, and Pali Gemma is one of them. So currently, recurrent Gamma is available in 2 billion and 9 billion parameter variant. 9 billion was recently released. And here is a code snippet for you. So how you import it, then you ask what kind of variant you want, say 2 billion IT model or 9 billion IT model or just simple 2 billion or 9 billion model. Then get your checkpoints, what the model checkpoints, you select them and download from Kaggle. Then you just load those parameters and write down a model configuration. So what we are doing is we are just automatically loading the model checkpoint and checking for configurations and just passing those configurations to recurrent Gemma model. giving it the device and the kind of data type, and finally loading the state. So this is the interesting part. When it comes to text models, I hope you have it clear that how LLMs work or how any NLP thing works. You can't just feed tons and tons of text by itself. You have to break the text down. That is what a tokenizer does. So think about it. You have a very small pipe, say a radius of 5, right? And you have a whole ton of water that you want to pass through it. You can't pass all the water at the same time. You'll have to divide the water and it will go through it in parts. It won't go all in the same time, right? It will take some time to go through it. Same happens with the text that you are passing. So when we talk about any NLP application, we talk about tokenizer. We talk about breaking the text into tokens and then passing it to our model through by making it a vocabulary, right? So what we're doing here is we are passing a vocab. What we're going to do is we say sampler, recurrent Gemma model, and in the sampler, we pass in the model and the vocab. Now, we are not we are not giving the input to the model as a whole. We'll be giving it in batches or in samples. So here is my input batch that asks, what are the planets of solar system, right? So it gives 300 generation steps. That is the total steps that would be required for it to generate my answer. So out data, I just use a for loop to get the out data. And here is what I got in result. So my prompt was, what are the planets of solar system? And it gave me an output that gave me the answer for gave me answer for each and every planet, as well as told me about each and every planet as well. This is not the whole answer, it's just a cropped version. But yes, it gave me the related terminologies and related things about each and every planet. So this is a pretty easy example that you can try for. Now, let's leave all that behind and think about Pali Gemma. So Pali Gemma is very interesting model, and it's very interesting to me because it includes vision and language both. It's inspired by Pali 3, and it uses two components. One is, of course, the Gemma model because, of course, Pali Gemma, and second is the Siglip vision model. Siglip vision model is more like a clip model, but in a slightly tuned different version. So it takes in both image and text as an input and generates text as an output, supporting multiple languages. So when I told you that recurrent Gemma just is available in English, Pali Gemma is available in multiple languages. So it is designed for class leading fine tuned performance on a wide range of vision language tasks, such as image, video captioning, vision question answering, reading, object segmentation, and object detection, one of my favorites. And you'll get to go through this as well. So there are three types of Pali Gemma models. First is the pre-trained models that are trained on large data sets without some specific tuning. We have talked about it a lot. Then fine-tuned models that are fine-tuned to a specific task. But there is another set of models that is a mixed model. So mixed model is a combination of pre-trained models and fine-tuned models. So it has elements of both. Here is an architecture of Pali Gemma model. It's a composition of transformer decoder and vision transformer image encoder having around 3 billion parameters. See for yourself. It takes an image input and text input at different levels, and it processes it all those two together through Gemma layer and gives you a text output. It is trained on Pali 3 recipes and uses an image encoder that is initialized from Siglip. We'll understand about Siglip a bit more, that is an image encoder. So first, you take in an image as input and pass it to Siglip image encoder. What this encoder does it takes it in image and processes it vis- processes all the information and transform it into a format that can be understood by the next layer. Obviously, we don't want a layer mismatch. But what best thing is about it, it takes in the image and it encodes it into a dense vector. So image is no longer a RGB image, it's a dense vector. Siglib is a sigmoid loss function for language image pre-training. It's an encoder that processes the visual information and transforms it, right? So once you had your original image, now after Siglip, it's a encoded image representation or a dense vector, right? So here, Siglip is more like a clip model. We already said here, Siglip introduces a straightforward modification widely used in the clip architecture. So clip models are originally used where they take in an image and take in a text at the same time and are used to generate new images. The SIGLIP also use the same clip architecture whose encoder and decoder are transformer based models. So think about it. If you're not really clear about these kinds of models, go back and visit the Transformer original paper and understand it in depth to understand these models much more better and how these operate. So once we have that embedding, see for yourself. So what Clip does is it takes an image, pass it to the image encoder, it encodes it, takes a text input, take it to the text encoder, and you have a matrix like this. It's called a vector embedding, where one side represents the image encoding and the other side represents the text encoding. And what the best embeddings are in the middle, the diagonal that matches it. Next is linear projection. So the next layer, now we had a vector representation, but now what we want is that the layer that is a fully connected layer or the projection layer, it converts that high dimensional encoded vector into a space that is compatible with the next processing stage. Of course, when we write a model, when we are designing a model, each layer or each adjacent layer is dependent on the previous layer, and we want such that all those layers are compatible with each other, all those adjacent layers are compatible with each other. So the encoding or the embeddings that we got from Siglib are compatible with linear projection such that they're compatible with the next layer. So what the linear projection does it takes the high dimensional encoded vector and it compresses it into a space that is compatible with the next stage. And the next stage is concatenated tokens. So now the output of linear projection is projected vector. Now we have a text input as well. Earlier, we were just messing around with image input. Now we have a text input as well. So at this stage, what we do is we take in the text, the projected image vector we have, and now we have a tokenized text input as well. Because earlier I have showed you that any text that goes input into any model, it's first tokenized. It does not goes around as a text itself. It's tokenized into tokens. By combining these two vectors, the model is considered for both visual and textual information simultaneously. So now we have concatenated tokens and we have the embeddings as well. So the input to this concatenated tokens layer is a projected image vector and a tokenized text representation. And both of these are concatenated together like a combination so that we can feed them to our original Gemma model. So consider something like this. I originally gave you this example that we have a cat. We take cat as an input image. We pass it to the siglip that gives us a high dimensional encoding. Then we pass it to the linear projection layer that gives us a that converts that high dimensional into a space that is compatible with the next layer, like a vector. Then we have tokens from the input, text input, say that says identify the cat breed. Then we concatenate those two tokens together and we pass it to the Gemma model. And the Gemma model gives us the output, that is what kind of identify the cat breed. And the cat breed here is Maine Coon. So let's give it a try. Uh, yes. So if you are a really beginner, here is an example for you. And if you are a bit advanced level, we'll move to the next kind of code example that you can try on, right? So first, if you have your code labs ready, you can do one thing. I have these code labs notebooks available on my GitHub. You can give just scan this QR code. I'll just wait for around 2-3 minutes so that you can scan this QR code, go to my GitHub repository, access both of the IPYNB notebooks that I'm going to show you, and you can try them for yourself. One notebook is authored by me, and the other is authored by Google, and they're pretty easy to follow. So you can just scan this QR code, go to the repository, and just follow me if you don't want to run the code by yourself. Just follow the code along, right? You'll have a much better understanding what's happening. Then I'll just wait for around a minute or two. Meanwhile, if you have any questions, just drop it in the chat box. Is it possible to teach Gemma 1 GB of code that we already have? You can, but not directly into 1 GB of code. You should break it down into parts. You cannot just feed it 1 GB of code by yourself. Gemma models are actually easy to fine tune and you can fine tune them easily. But I'm not really sure about if you can just directly fine tune them on your code. I've not seen some example of that sort, but yes, I think you can. So if you are done with the QR code, just go ahead and follow me. So first, what we do is we get the installs, of course, transformers and theft. Theft we won't be using. It's just for fine tuning, so we won't be using. But we'll be using Hugging Face Hub. So just go ahead and get your logins and everything. Get your token access tokens and make sure that you don't mess up with your access tokens or give it away to anyone in public. So if you don't know how to access your tokens, I'll just give you a quick demo how you can access your tokens. So this is my Hugging Face page. Just click on your photo, your image, your profile on the right hand side. Go to settings. Then in settings, you have to go to access tokens. On the left hand side, you will see 1, 2, 3, 4, 5, 6. On the sixth is access tokens. Just go ahead and create a new token. It will ask you what's the name of the token or what's the token is for. Fine grained custom token, it's for reading from Hugging Face only or writing to Hugging Face or just fine for a custom name and just go ahead and click on generate a token. Once you generate a token, you will have something like this that you can copy just once. So make sure that you copy it, you save it somewhere in your notes or somewhere so that you don't lose it. Or also, it also shows here that make sure that you never post your tokens publicly because recently Hugging Face was prone to some attacks and most of our tokens were available publicly. So, sometimes we do take workshops and we send those um, notebooks. People try those notebooks, and the tokens are publicly available, so people who try them and they can use it sometimes. So make sure that your tokens are not public. You use them very carefully and never share them with anyone. Right, so now you know how to get your Hugging Face token. So when you will click on Hugging Face CLI login, it will ask you to pass in your token over here. Then it will ask you to add token as Git credentials, yes or no. It's just connect you to your GitHub. That's it. Just come to the main part. So get to the imports. Here we are using few libraries. First is the PIL library that is used to work with images. Then it's the torch because we're writing in PyTorch. Then requests. It's sometimes used, sometimes not. Just mainly making some requests to the servers. And then or we have from IO because we are using Bytes IO library. We want to import that. Then matplotlib for simply plotting stuff. Transformers library because we are using Hugging Face to use the Pali Gemma models there from there, right? So if you're not really aware about Hugging Face, I'll just show you, give you a very brief of Hugging Face as well. What is Hugging Face all about and things. Let me just go ahead and yeah. So Hugging Face is a community where you can, search models, data set, and work around things. You can get new ideas. You can share your ideas, share your data sets, your host your models, host your spaces, and something of those sorts. And you'll get a lot more trending models here where people have already fine-tuned the models for you. You can just go ahead and just use those models directly into your code. And they also provide you a whole lot of resources as well. So you can just try them yourself, right? So you can use models from here. So say stable diffusion model, stable diffusion 3 available, Qwen 2 model that was recently launched, Llama 3 models, these are all available. You can use directly from here. Then data sets, if you are, you are looking for some kind of data set, you can just search from here, like computer vision, natural language processing data sets, or audio data sets, tablet data sets. Of course, Kaggle is one place to go to, and you can also go to Hugging Face for that. Then spaces is something that I originally showed you, where you can also deploy your models to get inference from. So if you don't want to create a whole Android app to showcase your projects, you can just showcase them on the spaces. They provide you, I think, two CPUs for free. So you can host your models here and just run them and give the inference. So people can actually experience and make inference on your models in real time, right? So that is that. Then coming back, so we set the device. So we set the device, torch.device. So if a GPU is available, we'll go for GPU. If it's not available, we just go for CPU. Model ID, what kind of model we are using? We are using Google's Gemma 3 billion mix. So remember when I talked about Pali Gemma models? Pali Gemma models are three variants. One is the pre-trained model, one is the instruct model, and one is the mix model. So this is a mix model that is pre-trained and instruct both combined, elements combined together. And then we just call the model saying Pali Gemma for conditional generation. Conditional generation is when we are providing some kind of prompt. We are prompting the model and giving certain conditions to generate something. And from pre-trained, because we are using a pre-trained model, and model ID, we're passing the model ID, right? Then processor. So auto processor, we use auto processor here so that we can immediately process our model. So pass in the process model ID and the kind of data type you are using. It will take some time, but here's a caution, a piece of caution, that this processing takes high RAM. So taking high RAM means that your RAM would overshoot and you will have to, you know, change your runtime again and again. So it's very much important that if you have access to changing the runtime, what you can do is you can just go to change runtime type here and just click on high RAM. So if you're a pro user, I think this is available only on Google Colab Pro. Just turn into high RAM, right? That will help you so that you don't overshoot your RAM. Then input images. You just take any file, any image, a link that you want to use. You pass in the image as a raw image. So we're using requests here, request or get that image, stream equals to dot raw, and convert that image into RGB if it's not, and then just show this image. So this is the original image. Next, we pass in the prompt. What is the flower called? We pass in the prompt to the processor along with the raw image, and we ask it to return the tensors, that is PyTorch, peak tensors, right? Then the output is model.generate. So we ask the model to generate an output, passing the inputs and the maximum new token size, that is 20 here. So the generated output would be limited to token size of 20. Then we print the processor.decode. So of course, first is we have the model. Let's go back and see. First, we have the model through model ID. We call the model, right? Then we have the processor that will process the image and everything and pass it to the model. Then we have our image. Then we have a prompt. So image makes the vision part. The prompt makes the text part. Both are given to the processor. So prompt and raw image both go into the processor. Then processor passes those inputs to the model, that is model dot generate, and passing those inputs to the model. So model generates an output, and we use processor dot decode to decode that output that was generated. So what I asked was, what is the flower called? And I got the answer, Daisy. So flower is called Daisy, right? Similarly, it's a kind of a very interesting thing that I tried. I gave it an image. This is some delivery receipt, and I asked it identify this one. Describe the logo on the receipt, and it gave me an output truck. People have done multiple things on using the same techniques, and you can fine tune this model as well. I think Pali Gemma is also available to fine tune, and you can do that locally as well. A very interesting thing that you can do with Pali Gemma, and when I talked about Pali Gemma, was that you can use Pali Gemma to detect some entity in the prompt. So for example, I give you this image of a cat and I ask you to detect that cat. So Pali Gemma would actually give you the bounding box or the specific coordinates that defines this cat. So when I told it to detect cat, it returned the output text was leave this image apart. It returned this coordinates to me, right? So it actually returns those coordinates to me. So what these coordinates can be used for is you can do object detection, you can do object segmentation, and can be used in different applications. Here we are just detecting cats, maybe in self-driving cars as well, something of that sort, right? And of course, these models are under process. So just don't tell me you use it on your own cars and you bashed it into some tree or something, right? And say, ma'am, you said we use Pali Gemma for this. Don't do that, okay? So yeah, this is one thing. But if you are a very beginner and you want to try something of this sort, you can just give it a try and understand that what we learned about Pali Gemma. So if you go back again, Pali Gemma was text input along with image that was encoded and pass it to a processor, both of those things, an image and the prompt, pass it to the processor, and then use model.generate. Through what comes out of the processor, you just use model or dot generate on that, pass it to the model, that is the Gemma model, right? And then you decode what you got in output, as simple as that. But if you are someone more enthusiastic and you want to try more examples on Gemma, here is something that is a notebook that is given by Google, and it's already free for anyone to try. And it does not require a Google Colab Pro account. So you can give it a try very easily. Let's understand it. First, it uses Kaggle username and Kaggle key. So if you are a Kaggle user, good for you. If you're not, I'll just tell you how to, get your Kaggle user ID and passcode and everything. So this is my Kaggle account. Let me just go to settings. You click on your own image and you go to settings directly, right? Then go down under API, click on create new API. But I already have a API key, so I'll have to expire my previous one. But you can just follow the steps and you'll get a kaggle.json file. Once you get that kaggle.json file, you can finally extract the API key from that. It's very easy to extract. It's just one line of code in the JSON file, and you can identify which one is the API key. You pass in the API key. So here is something I want to tell you. So how you do that? You go to secrets. Here are a number of keys that I'm using right now. So here is my Kaggle username. So Kaggle username is nothing, just your username. So mine is Aashi Dutt 3. To go to profile, here's your Kaggle username, Aashi Dutt 3, right? The API key you already have. Pass in the user key, username, and the Kaggle key here, and just activate both of these. Even if you don't activate this, when you run it, it will ask you to by default activate it. Nothing to worry about, right? Now we're using Jax as a backend because Keras 3 allows you to use Jax as backend. The best part about Keras 3 is you can use multiple backends. You can switch into multiple backends with just one line of code. So if I want to convert from Jax to say PyTorch or TensorFlow, I can just do it within this line only, right? So when you run this, you have all your imports done. Then install Keras NLP. This helps you to get your models because all the models are under Keras NLP library. Then all the basic ones, Keras NLP, NumPy, PIL, request, IO, RE, matplotlib, PIL again for import images and everything, right? Once this is done, let's get to the actual part to download the model checkpoint. So how you create a how you download the model checkpoint. The best way to do this is use Keras NLP library. Through that, you just say which kind of model you want. Here we are using Pali Gemma causal LM. So make sure that you know what kind of model you're using. Pali Gemma causal model, it's somewhere here only. Wait, here. Pali Gemma causal model is a pre-trained Pali Gemma variant for vision language modeling and use it to create a model, right? So what we are doing here is Pali Gemma causal LM is a pre-trained Pali Gemma variant for causal visual language modeling, right? Going back here, we get the model, we say what kind of model we want. Here we are using 3 billion mix model and we get the model summary. Model summary remains kind of same. We are using Pali Gemma backbone, the base Pali Gemma model. And of course, we're using the rest layers as it is, input layers and output layers as it is, right? We won't go much into depth, but what we're going to do here is we have few functions like cropping the image that you're getting, reading the image. Of course, you want to read the image and you want to crop the image according to your size and everything. Then if you want to make some bounding boxes around those images, so how do you do that? Remember when we went to the last part of this, we saw this one. So this is a raw kind of thing that you receive. This is a raw output. But the only useful thing out of it is this location of the bounding box or the cat, right? Or the object and the entity that you want. We want to extract this location and remove all those image, everything, right? So how do we do that? We use read.findItter method and we do this. Through this, we just get the loc and the next numbers around it. So we get the exact location where we should place our bounding box, right? Where the cat is. So this is done through this function that is parse bounding box and labels. Then is displaying bounding boxes is just simple method, simple function that you use. You pass in the boxes, you pass in the image, labels, target image size and everything, and it will display a box around your image. And then segmentation, if you're doing segmentation, this method function would show your segmentation as well. So now test this model. So here is an image. It's a cow uh, on a sea, near a seabed or something, right? Near sea or beach. And we asked it, prompt answer, where is the cow standing? And it answered correctly, the beach, right? So what we did here is we passed in the image. We did the same thing almost. See, we passed in the image. We read the image. We passed in the image, that is cow image. We have a prompt, that is where is the cow standing. We pass both the prompt and the input image to Pali Gemma. Of course, we use dot generate method. Pali Gemma dot generate and passed in the inputs and got the output, that is beach. Similarly, you can batch these outputs as well. So here is number of prompts, number of outputs as well. So if you're asking answer where is the cow standing, it would say beach. Then what is the color? It would say brown. Then you describe, it will describe the uh, whole output as well. Then you ask for detect when it's a keyword. So if you say detect, it would give you a whole location. And if you say segment, it will give you the whole location of segment pixels as well, right? There are other styles of prompts as well that you can try, of course. So pass detect output. So here is how you create a bounding box. So we have a prompt that is detect cow, and the output is generate inputs. You pass the inputs and the prompt, and you say bounding, you call the function pass bounding box and labels function, and you pass in the output. So it takes in the output that was detect cow, this one. You pass in these to the function, and it would generate this bounding box for you. Similarly, you can do same thing. For segmentation, it uses Big Vision library for doing the segmentation. So you read the image. Here is the cat, right? So you use the big vision dot evaluators dot project Pali Gemma function, segmentation function basically. So it actually takes all those locations and the pixels that you get for segmentation. It gets the crucial information from it, labels it down, and then creates a segmentation map for you like this. Pretty interesting, I feel, right? But if you are someone more, say, you just like to experiment like me. You don't really want to write a whole lot of code. You just want to experiment with Pali Gemma. One thing you can do is go to Hugging Face Spaces. I already showed you. It's running on a T4, and you can just try a whole lot of things here. So I'll try a few things. Here's a Pali Gemma 3 billion mix model. I think it's just 3 billion mix models are only available here, right? So let's try. Say for example, segment cat, right? So you click on this, it will load the image for you, and then you can change the prompt as well. So let's just say segment the cat. Let's just let it be like this only. So Pali Gemma 3 billion widths fine tuned with 224 by 224 input. So 224 by 2. So when we say Pali Gemma 3 billion mix 224, 224 is the input size of the image. It takes 256 tokens input output text sequences on a mixture of downstream academic data sets. So let's just that be and say run. It takes around 5.4 seconds to segment out my cat. So here it segmented out the cat from the scene, right? Let's just try something else. Let's see how many balls are there on the table. I've already tried it. Let's try it again. So I want to know how many balls are there on this table. Let me run this. And I got the output 7. As simple as that, right? Let me try something else. See, for example, here it says how many yellow cushions are on the couch. So we see there are only two cushions. So let's see if it gives the right answer or not. Yes, it's right. Let me just try one more thing. Say segment um, cushions. I didn't use the right word, but okay, let's see. It did not take the writing. Let me say segment of cousins. No cousins. Let's say segment flowers, if that works. It did, right? So you can just give it a try and see how these models work around and try on giving different kinds of prompts to see how these models actually work around and give you a different space and you know give you a different idea of how these models actually work, right? So let me just take one final example. um, Say this one. What caused this? So what do you think? What caused this? I think some kind of storm might have caused. Yeah, it got the right answer. Say storm. Let's just try one more thing and say segment tree. It did, right? Let's just say can it segment out a bench? I see one bench over here. If it can. Oh, it did. And it did pretty good job at it. Since the size of the bench is quite small as compared to this tree, but it did a good job in segmenting out, right? It did cover some of the, background because the hedge did look like it was a bench, but yeah, it did a good job. Let's see if can segment out grass. It's pretty generic. I don't think it can segment out grass, but let's see. It did. It did capture the grass over here, but it did not manage to capture the grass over here. So these models are work in progress and they work good enough. And you can try and get some hands-on projects on these. Try and work out of box and work around with these models and see what kind of prompts generate good outputs and see what prompts don't work and just report them back, right? So you can go ahead and give these notebooks a try and see if they work out for you or not. Also, while we are at it, uh, there are certain notebooks that are available on Kaggle as well. So if you are an active Kaggle practitioner or not, let me just go ahead and show you some of the models that are available on Kaggle. So Kaggle models, these Pali Gemma models or Llama 3 or Gemma models are available on Kaggle as well. And you can try them. So if you can see, just go to models on the left hand side of your Kaggle page. Just log in and go to models. Click on Pali Gemma. You'll see you have five variety of these models, five variations of these models. And you can try it with Jax as well as with Keras. So variations are here. So you can try it with pre-trained 224 that takes 224 image sizes input or 448 as input. And then you can try the mixed versions. You can try the pre-trained versions by yourself, depending upon the kind of image size you want to work with, right? You can just work easily with these models and see how they work out for you. Okay. Yeah. I just lost my internet. I hope I'm back. Yeah, let me just go back. Yes. So, yes, I was on Kaggle, and you can see for yourself that there are multiple variations of these models that you can try. You can try for Pali Gemma, you can try for Gemma models as well. So, if you go to models back, okay, yeah, you can try the Gemma models as well. So, you can see there are 59 variations of Gemma models. Yeah, here you go. So few are managed by Keras that are pinned. So there is Gemma 1.1. It's a very pretty old model. Gemma 2 billion model that we worked with, Gemma 7 billion model, and rest others. So you can try and work around with these models over here, or you can just go and run them on Vertex AI in Google Cloud. So if you're not well versed with Google AI, Vertex AI Model Garden, here is an outlook for you. I'm not really logged into this, but I can give you a really quick overview to this. So, Vertex AI Model Garden. So, if you go to Model Garden, I think my internet is very, very slow today. Okay. Yeah. Here. So if you go to Model Garden over here in Vertex AI, you can see the kind of modalities that you can work with or the kind of tasks and the models you have for different tasks. So maybe for generation, classification, detection, extraction, recognition, segmentation, all these models you can try with. And especially the Gemma and Gemini versions you can try for. So Gemini 1.0 Pro is available in Gemma. Let's see what all we have available in the Model Garden. So the point is that you can work around with Gemma models in any form that you want. You can work with them in your Kaggle notebooks. You can work with them on Google Colab, on Vertex AI, wherever you want to deploy them, right? So you can deploy Gemma models in Vertex AI as well. You can have the whole use cases, documentations, then licenses, everything here, and you can try like a demo or prompt something as well. You have to be connected to the server as well as you have to be sure about the billing. I'm not really sure about billing. I've not set up the billing for this account, but yes, you can work around with that in Vertex AI as well, right? Yeah, that is for Pali Gemma. And of course, there are some limitations. So I've talked a lot about Gemma models and how crazy good these models are. But Gemma models have some limitations, and Pali Gemma also has some limitations that comes from the underlying Gemma model. Of course, these are LLMs. They can hallucinate. They require clearly framed prompts, clear framed instructions. They are, open-ended questions like, some random questions that you throw at them that are very open-ended. These might be challenging for them to understand. They can, struggle at times to understand the nuances or, sarcasms that we as humans generally easily understand. And at the same times, these are VLMs and the responses are learned via the training data set that they were given off. So when we talk about responsible AI, when we talk about fine tuning models, it's very important that the kind of model that you're feeding into these kinds of models is it's very important that you make sure that the correct kind of data set is passed into these kinds of models. And there's one quote in the AI world that goes by garbage in, garbage out. So that is the same thing true with these kinds of models. If the kind of data set that you're passing it is garbage, don't expect flowers at the output, right? So VLMs generate responses that are learned from the training data set. So they don't have knowledge bases. So if it says that it does not have, some incorrect information, or say the model was trained on data that was till yesterday's data, and you're asking it something about, say, what is the score of India versus Canada match that is happening right now, and it is giving you outdated factual information that it does not have access to. But of course, you have rags, you have certain new techniques that you can use. You can use APIs along with that, so that you give it some real-time information as well. But yes, that is a topic for another workshop or another discussion. Then VLMs rely on statistical patterns and in language and images, so they might lack the ability for common sense reasoning that humans usually have. So don't expect to give you good answers or good right. So that is something that comes under responsible AI, that it is your responsibility as developers that you make sure that whatever you're feeding, kind of data you're feeding, you make sure that it's the right kind of data, it's a clean data, the data set is not corrupted in any sense, it does not have anything that has some negative repercussions, and at the same time, the method of extracting that data, it covers all the privacy related things, that it does not harm anyone's privacy at any cost. So all these things at large makes us, it covers a long things around limitations of these models, but these have a good, understanding of LLMs and how we have come from transformers in 2017 to VLMs in 2024, and the models are trying to get better and better each day, right? So these are some limitations of these models, and here are some resources for you. So these resources for you is also available in the README section of the repository that I shared with you, and you can just go through all these kinds of things. So I can, we have some time on our hand, I can just quickly go through all these kinds of things with you. So first thing is a Gemma official documentation. So here it is. This is a Gemma official documentation, and it's very easy to understand. So all mostly the kind of data that I showed in my presentation is from this. This is the Google AI for Developers original documentation. So it will give you a very overview to the Gemma models, that is the Gemma base model. Then you can understand what kind of models are available in Gemma family. So Code Gemma, AI assisted coding for with Code Gemma and everything. So you can try for yourself. So here is something I was about to show you. So I talked about, multi-line code completion with multi-line. So what was that? Was that you specify where your cursor is right now, where it was before, after, and at cursor. So you just, mark the right cursor position. So this is all done in the prompting section, and you just give it the starting and the end, and the rest is assumed by itself. So before and after, you pass in the prompt of format completion, and it completes the whole thing for you. So this is Code Gemma for you. There's still some things in work, so you don't expect them to be flawlessly brilliant at what they do. They are just some things that are in progress, in process, and you can try these examples on your own. With every example, you can find, so there is a model card. You can see what all links are available, what kinds of data sets these were trained on. You can see in the overview, you can find some of the examples. So say run in Colab, view on Kaggle, view the model card. So you can run these in Colab for yourself and try these examples out. So right, one thing is this. Then you can go to releases. So currently they released 9 billion variant for recurrent Gemma. Then in May 2024, there were they release Pali Gemma, all these kinds of things they release. So you can keep update with what's new in Gemma family. And yeah, of course, Gemma family is very much different from Gemini family, because Gemma family has a very strong holding on language models. Multimodality is something that Pali Gemma is trying to achieve, but we don't really call it a multimodal model. but at the same time, Gemini has achieved that thing, but it still has its own, pros and cons, and Gemma has pros and cons as well. So this is one thing that you can try for yourself. Then is this very interesting blog by Ritvik Raha. He's also a GDE, and that is understanding Pali Gemma. So he takes you through all these things that we just covered in a very brief manner. That is, what is Pali Gemma, what's the architecture like, Gemma, Siglip, and everything, architecture thing, data sets that are used, fine tuning, and everything. It takes you through code and some other things as well. So this example that we already saw on Hugging Face Spaces, we have used the same thing. And yeah, rest of the things I have covered. But you can give it a read. It's a good read for you. Next thing is how to fine tune your Gemma 2 billion. So here is a blog post for a work that I did with another fellow GD, Nitin Tiwari. And you can follow this. You can get the link to this on my GitHub repository. And this is a 3 blog series where you, from part 1 to part 3, you'll first build your own data set from a science book. Then you will fine tune a Gemma 2 billion model. And sorry, finally, you will create an Android app to deploy that model. So that these are two things that you can look into. Rest, the Gemma original um, document in itself, it's a complete document, and you can try inferencing it using Jax, Flax, maybe try it chatting with Gemma or something of those sorts, or maybe just go ahead and if you want to understand it more into Google Cloud, just try it on Vertex AI as I've already showed you. So these are few things that you can try, and yeah, just if you want to, just you can click a image of resources for you page, or you can just click an image for this as well, the QR code. And I think we're done for today. I yeah, I'll just give it like a 2-3 minutes for everyone if they want to scan this QR code. So the repository would be really helpful for them to try on. It has lots of resources that they can, try, and then we can take in some of the questions if there are any. Cool. Let's just see. What are good Gemma alternatives? There are a lot many LLMs that are available, but I think if you want to experiment, why not experiment with the variants of Gemma? So Gemma, when we say Gemma, Gemma is just the base model. Gemma model, a base 2 billion model or the 7 billion model, it did work for us good, but it did give us some of problems when it came to fine tuning or getting correct answers. So a very peculiar thing that comes with these kinds of language models is that they hallucinate a lot, and you have to get the right kind of prompt to in order to get the right answers. So if you want to, say maybe try on llama models. Llama models did really well. I have no idea about Quen model, Quen 2 model that was recently released, but I tried Llama 3 model by myself. And one of the LLM models like Llama 3 model, you can try it for yourself. Llama 3 gave me pretty good results. So if you want to try, you can try Llama 3 using Llama also. If you want to try to work locally, because I think people are trying to go towards edge AI side. So trying these kinds of model locally, and I think Pali Gemma is also available locally. Gemma is available using Olama, so you can try that as well. Some suggestions to make mobile app fast, responsive when using Gemini 2 billion. So there are a few things that you can do. One is quantization, and the other one is compression. So you can compress these models and convert them using Onyx so that your model size reduces. But I don't think so. You really want to do that with Gemini 2 billion model because it itself is a very small model, and when you deploy it using deploy it on your Android device, it hardly, for us, it made like 2 GB model. I think we use like games, we have more than 2 GB games in our memory. I don't think so. You really want to make it that fast. It was pretty fast responsive as well. If you have seen the GIF that I showed, it is pretty fast in that. The response is pretty fast. Can the text OCR able to tell when it is an article with columns? Sorry, I didn't understand the question. I think if you want to try text and OCR together, you can try with the if you want. I don't really understand the question, Jivila. Could you just rephrase it?
Yes, I was wondering, like, if you pass it an article, like a newspaper article, is it able to tell, like, when the article switches to a new column? Or is that something that you would have to train it? I'm not sure if you've had any experience with that, like if you pass it an
Um,
article, like a magazine or a newspaper.
I haven't tried that personally, but yes, it makes a pretty good use case for that. I'll give it a try definitely, and if you do, just reach out to me and we can work on something around that.
Thank you.
Thank you. Okay, I think there are no more questions. Please email the link as well. Acha, okay, recording. Okay. I think we covered all the questions. If there are any other questions, you can just unmute yourself.
How do you know when you're fine tuning, like, uh, do you stop when you get to a certain percentage? Is that when you're kind of know when you're done pre-training? When you're, what percentage do you usually try and get to?
Yes, usually that is the case, but sometimes, uh, it's it depends upon the use case. So for some of the examples, what happened with us was that we were working on some kind of project, and what came up was that we were trying to fine tune on a language model on some kind of text. But what happens is that sometimes you really don't want to fine tune your model on some things because it repercussively declines or decedes the original accuracy of the model. So it has to be dependent upon what kind of use case that you want to achieve, and simply fine tuning. And if you want to see if your model is actually fine tuned or not, it's more of test around the kind of prompts that you want to pass it and see the results and check with different kinds of prompts. Maybe use like function calling or something. Try different prompts, find out what prompt works best based upon the threshold or some kind of accuracy or some kind of benchmark to see if your model is fine tuned correctly or not. I hope that answers your question.
Yes, thanks. And what happens, like, if you get to the point where it's actually going down instead of up, like you said? Do you, like, is there a way to roll it back once you start, like, training it and it's gone the wrong direction?
So one of my seniors actually told me to like don't fine tune it, because you don't really there is no really need of fine tuning, right? So you are just trying to fine tune it on your own data set, but that information that you're passing to the model, that is already available in the original data set it was trained on. So it's really kind of harsh on the model itself. So it's better to roll back to the original thing only, on which it was giving you better answers. We
Got it.
have one more question. Can Gemini 2 billion mobile app be deployed on another OS than Android in case of Flutter? So I am not really a Android person myself. The Android part was done by my partner, but I think yes, it can be done on Flutter app, but I don't think it's compatible. So, the library that we were using, I don't think it's compatible with Flutter. MediaPipe does not support Flutter right now, I think. You have to check with that. Or if you have some other library through which you can deploy, you can try on that. But I have no really idea on that. Hold on. Shaira, can you just share the recording with me as well? Yeah. I hope I pronounced your name right. Ah, that's better. Short and sweet. Definitely, definitely. There are more things coming from Google's side, so just stay tuned. And there's a lot more things people are working on. So, and if you have any, great ideas that you want to implement, say like small ideas that can have huge impacts, and that can be done through Gemma models or Gemini models or any other models that you want to try, just uh, hit me up, ping me anywhere. You can, I'll just share my LinkedIn and Twitter as well, that you can just connect with me on my LinkedIn and Twitter. Uh, so that if you have any questions also, or you have any cool ideas that you want to try, just let's connect. This is my LinkedIn and this is my Twitter. So if you have any, queries, or you wanna just connect and chat about what's new, let's just connect, and hopefully we'll be building some good things together. So thank you all for joining in today, and I hope to see you all again. Thank you so much.